All right, so really briefly, we're going to talk about the Cartesian definition of perpendicular lines. And in it, uh, we see we have this conjecture, and if we take a minute to read it, and if you need to pause, you can. If we take a minute to read it, we know that it's absolutely true. If two equations are perpendicular, then that means their slopes will be reciprocals and have opposite signs. Okay, so let's look at an example of this. Right, so I programmed up a graph for us to look at. Hopefully, it'll get the point across. No pun intended. Anyway, so here we see we have, y equals mx plus b. M right now for us is 0.25, which means 1/4, right? For them to be perpendicular, they have to have opposite signs and reciprocals, right? So we see here, we're obviously at a 90-degree angle, okay? So anytime that I change into whatever it is I need to change into, we see we have opposite signs and reciprocals, right? And it's going to be pretty tough to see that when we're using decimals. So, for example, if I go ahead and put, let's say, -5, right? Perpendicular to that is going to be positive 1/5, which is positive 0.2. Okay, and we can see that that works here, right? So that gives us our Cartesian definition of perpendicular lines. Um, if you were here in class, you would have had time to figure this out on your own, how to make the two lines intersect at a perpendicular line or at a perpendicular, like a 90-degree angle, right? But that's all this means here. So here is our Cartesian definition of perpendicular lines. It's simply that if they're going to intersect at 90 degrees, right, then these two things must be true. Their slopes need to be reciprocals of one another, and they must have opposite signs. So, for example, let's say I had y is equal to, I don't know, 1/3 x plus 3. Okay, well, this is going to look something like this. So here's positive 3, 1/3 x would be slanted about like so, right? And now let's say, perpendicular to that, well, if I've got 1/3, opposite sign would be -1/3, right? So I'm going to say op sign, right? And reciprocal, well, now I'm going to flip the number over. So that's -3/1, which is just -3. So -3x. And then the y-intercept doesn't matter when we're talking about perpendicular. Y-intercept does not matter. So I could go ahead and say -2. Who cares? So if we're at -2, right, I know that I'm going to have a steeper incline because I'm at -3, and I'm going to be slanting the opposite way, right? And this angle here where they intersect is going to be precisely 90 degrees because I have slopes with opposite signs and that are reciprocals of one another. Okay, so if you have any questions about how this works, obviously come and see me. This does get confusing, just because we always tend to forget what reciprocal means, and because it's two things, right? It's not as simple as parallel, where they just have to have the same slope, different y-intercept. This is a little bit more difficult to try and remember. But as always, any questions, come and see me and or shoot me an email. Goodbye.